The critical infrastructure challenges is one section in the Resiliency and Public Policy video series. Let's review the resiliency challenges of the critical infrastructure. The critical infrastructure is composed of the numerous industry sectors that do the heavy lifting. Some key sectors are listed here. Utilities and energy contain power generation and distribution systems, nuclear power control systems, and energy resource allocation systems. Telecommunications contain network control and switching systems, satellite control and management systems, and mobile communication systems and protocols. Banking and finance contains electronic commerce and electronic funds transfer systems, transaction processing systems, security and privacy management systems, and network management systems. Transportation contains route management and collision avoidance systems, avionics systems, air traffic control systems, navigation and position location systems, and embedded automobile control systems. Medical systems contain medical device control systems, patient record systems, and insurance payment systems. The operations within the industry sectors of the critical infrastructure are diverse and complex. These industry sectors comprise an accidental system of systems that intersect operationally without a plan and design in advance. Each sector system was constructed within its own context and culture. In operation, these sector systems may inadvertently impose their own context and culture on others and clash with uncertain and unintended operational results. Industry sector practice varies widely in their domain engineering approaches, resulting in diversity in architecture, models, and patterns, including their representation. Formality within an architectural framework facilitates the imposition of distributed supervisory control, interoperability, and operation sensing and monitoring protocols. Industry sector maturity in management and engineering processes varies widely, resulting in diversity in configuration management, frequency of release, conformance to requirements, and traceability among lifecycle artifacts. Strong code management practices facilitate reconfiguration and reconstitution. Industry sector practice varies widely in fielding and operating practices, resulting in diversity and accountability and control, supply chain management, civility and pushback, and willingness to expend off-the-clock effort. Exercising strong control over the workforce facilitates business continuity and survivability. Industry sector impacts from government regulation vary with respect to export control, tax policy, intellectual property, privacy, and antitrust litigation. Exercising strong government control facilitates compliance for the benefit of the commons at the expense of initiative for the self-interest. Industry sector public expectation and confidence vary with respect to trust, loyalty, and satisfaction. The financial and medical sectors depend on public trust. The electrical and telecommunications sectors depend on customer loyalty and satisfaction. If the critical infrastructure is to be resilient, its sector managers and systems must respond to guidance from intelligent middlemen whose influence is felt before, during, and after a crisis. Intelligent middlemen possess the broad range of hard and soft skills spanning the cultural, ethical, legal, business, process, management, and engineering dimensions needed to meet the challenges of the critical infrastructure in anticipating, avoiding, minimizing, withstanding, and recovering from cross-cutting effects and to impede the emergence of propagating and cascading effects. The intelligent middlemen are positioned at the center of things and serve as the traffic cop for identifying and driving resolution of cross-cutting issues. From this vantage point, the intelligent middlemen are able to obtain superior situation awareness. For example, they ensure that recovery time objectives are coordinated, interoperability protocols are followed, distributed supervisory control functions are coordinated, and operation sensing and monitoring functions are applied. Beyond just the critical infrastructure, the Homeland Security Information Network, shown here, begins to capture the broader demand for resiliency. Here we need to strike an intelligent balance between two extremes, where no one knows everything and where everyone knows everything. We need to adopt the intelligent middleman approach, where highly qualified middlemen know as much as possible, know how to acquire additional information, know how to connect the dots, and know how to act on what they know. Of the 36 entries comprising the communities of interest shown here, how many do you think are secure? Can anyone name one entry that is secure? Now consider the Homeland Security Information Network itself. To what extent is the network resilient? Just as important as the answer to the question is the means by which you arrived at the answer. How does one assess the assurance of resiliency?